Morning.
Morning.
I don't think so. Did we have a work summit? Oh, yeah, we did, look at that. When did you check this? Because I checked it like,
Well,
I checked it last night, and it wasn't updated.
That was, the focus up was there yesterday.
It was?
It was there Tuesday, yeah.
No, it wasn't. Well, not for us, at least.
It was.
No, like I can't, don't tell me that, because I have to worry about it.
Here was Tuesday.
Yep. Oh,
We just didn't get to it.
yeah, because we were slow, that's right.
Well, it's just that stuff took longer than I expected it to. None of the classes got to it.
You would think that, due to the snow, that they consider canceling school today, but, you know, here we are.
Well, the streets are fine.
Yeah, for now. 60 degrees outside. I think it's gonna touch the road any minute.
What's the temperature outside?
16?
Huh?
16, around there?
Okay, so what temperature is the ground?
I'm not doing it with thermometer right now. I'm
Well,
gonna stick with
how do you know it's a problem if you don't think about it?
I'm sure the ground is just as cold as the air right
No,
now. No?
the ground is much warmer.
Alright, well, you said, I'm tired of feeling like that.
Council,
Yep.
you gave me a 0 for this on the.
Okay, just put it back in here. I'll get it fixed and get it back to you.
Okay.
Sorry about that.
I have some papers.
Okay.
I'm
Got
not
your
really
name
sure.
on them?
Yeah. I don't know what the policy is on my late work since I was gone for like 5 days.
How many classes of mine did you miss?
3 Thursday.
Okay. Then you got like
Friday.
3 classes to be all the way caught up. So,
This was on my desk, but it's not mine.
oh, sorry.
There's it.
Mr. Townsend, this is I only had one of my work for the Khan Academy. Turned in, I forgot this one at home. This is the other page.
Okay. You turned in what you had last time?
Yeah, it was just, it
Put
was
in
a
the
couple
box.
on from the
Make
last.
sure your name's on it, and then try and figure it out.
Tuesday was 89 and 94, right? Yes.
Okay, definitely 89, horse, yes,
Caught
94,
it.
yep, sounds right. All right, good morning, guys. I am asking for one assignment, so please get that to me during the minute of silence.
2025. Will you please join me for a minute? Quickly get to the flag the United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you very much. Great day.
Okay, last call for full points on 93. 93 was the separation of variable notes that we finished last class and started the class before. If I don't have yours yet, please make sure your name's on it and get it to me in the next minute so that I don't have late. Okay, this morning you will need a blank piece of paper, and you should have picked up a copy of the book assignment. As normal, please don't write on this. I already used plenty of copies, so this is one that I can reuse pretty easily. There's not enough room to do the work on this handout anyway, so please don't do it on here, do it on a separate sheet of paper. And on your separate sheet of paper, if you want to go ahead and copy down the questions, it is 1 through 23, just the odds. So today is the day where we're going to do nothing but separation of variables. So 2 classes ago, I introduced it to you, talked about the process, the goal, the steps. But we also focused on U substitution that day. And then last time I saw you, we talked about how to deal with the absolute value signs, how to solve for the C, and talked some about how to check your answers. But you also did that U substitution quiz at the start of class. So we've not had one day totally devoted to separation of variables, so that will be today. So we don't have a ton of questions. There's only 12 questions total, so we're going for quality over quantity here. But go ahead and copy the assignment down, and then if you would go ahead and try question 1. Now, the answers to these, I did print out the back of the book, so the back page has the odd answers. So try question 1, and if you can get to that step that they have on question 1, then that's great. Check it off, and you can just move on to question 3. You don't need to wait on us. But I am going to try to be shortly behind you so that you can get any and all of your questions answered on this. Also keep in mind that this is the last thing out of Unit 7. So once you feel like you've got the hang of this, separation of variables, the big part, float fields, hopefully doesn't take you more than 5 or 10 minutes to review. Exponential growth and decay questions hopefully don't take you more than 5 or 10 minutes to review. So we'll still have a review day before your tests. We're also going to have a day where we just do some FRQ practice, and some of this is built into that, so kind of indirectly review. But in theory, you could be ready or very close to ready for your next test at the end of today's class. So let me shut up here and give everyone enough time. So again, either finish 1 and move on to 3, or work 1 till you get stuck and then move on to 3. I'm going to make sure that everyone's had time for number 1 before I offer to go over it. And again, my preference would be that you solve all the way down to y equals, but as long as you get what the back of the book has on the back page, then that's going to be good enough. If you can get to what they have, then we call that a win. Okay, does anybody want more time for question 1 before I go over it? Okay, so again, please only pay attention if you need to. Otherwise, use your time well and just keep on going here. Okay, so what might be a good idea if you realize that this is still, you don't have the steps memorized, is you might write on the top of your paper the steps that are consistent for all of these questions. So 1, you need to separate the variables. So for question 1, we have dy over dx equals x over y. So, all right, so step 1, if I separate the variables, this dy is in the numerator, so y stuff needs to move to the left, multiply both sides by y, and I can multiply the dx over, and then variables have been separated. On a FRQ, you would tend to get 1 point just for that step. Okay, the second step, the purpose of separating the variables is so that you can integrate both sides. Okay, and of course, sometimes this is going to be as messy as U substitution, but not often. So undo power rule, undo power rule. What I call the third step is remembering your plus C. That's the only one of the steps that I would call that, where it doesn't get more difficult. Step 1 can be more difficult, step 2 can be more difficult, and step 4 can be difficult. But step 3, just remembering plus C is not a big deal. Okay, and then step 4, the whole purpose of this is trying to find the original function. So I would multiply everything by 2. Unknown number times 2 is still an unknown number. And I would square root both sides. Okay, and if I compare to their answer looks a little bit different, but their answer is just a variation of this one. If you subtract the x squared over, then it looks like theirs, and then that's fine. So there's nothing better about how they wrote their final answer than I did, but just for the sake of multiple choice practice, I want to make sure that you get your answer to look like theirs so that you can at least practice making it look different.
So it doesn't always equal y?
Really the purpose is to trying to find the function y equals I think the reason why they wrote their answer that way is they just assume that once you get to this point, you should be able to finish it. You should be able to solve from y from there. But I couldn't tell you why they stopped y squared there, and on question 7 they go to y equals. So I'd say just always go to y equals before you check your answer, and then if it looks different, just see if you can adjust one of your previous steps to make it look like that, just like you would on a multiple choice question on the test. Sometimes you have the right answer, but it might look a little different. Okay, so if you don't understand any of that I did, that's going to cause you problems on probably every one of the other questions. So we need to iron out the questions as fast as possible, or the mistakes. So is there anything in here that you would like me to talk about again? Any of those steps you want me to readdress? Yes, right.
What happens to the dy and dx after you integrate?
They just go away.
Do they not turn into like just y, like times y and times x?
Mm-mm. This dy is defining this interval, so you know that y is the variable. This dx is defining this integration so that you know x is the variable. There's times where you need it, like if I ask you to integrate 1, well, what can you take the derivative of to get 1?
X.
Okay, you get x if this is dx, but if this is dy, it's not 1x, it's 1y. If it's DR, then you have one R. So we need, this doesn't produce anything, it just defines the variable for the integration. So after you integrate, it just goes away. It appears to disappear, but it is being accounted for. Okay, other questions about this number one? Okay. I'm going to leave this number one up. And then again, please take what you need out of that. Try not to make the same mistake on the next question. And in about 5 minutes or so, once I'm sure we're finished with number 3, I will go over that one also. I'm assuming we are ready to go for question 3. So again, if you could figure out how to get your answer to look like their answer on the back, then you do not have to follow along with me here. Doesn't sound like you'd get anything out of that. But if you got stuck, then you're probably going to get stuck for the same reason on other questions. So, also, a little bit of this didn't print out the best, so I apologize. I did the best I could here. Okay, so similar to U substitution, it is totally reasonable to think that this is one of the harder things we have to do this semester, but that doesn't mean that the steps that you need to do, you can't memorize those. At this point, you have practiced this enough that you should know step 1 is try to separate your variables. So you could subtract the x squared over and then multiply the dx over. Y stuff needed to go to the left, x stuff needed to go to the right. Again, that step can be harder sometimes, but it's just algebraic manipulation. At least there's not really any calculus going on yet. Step 2, the whole purpose of that was so that we can integrate both sides reasonably easy. So this one is undoing the power rule. This one is undoing the power rule. And step 3, don't forget your plus c. And then the real goal of this is to try to figure out the original function. So I can multiply everything by 2. Divide everything by 5. And square root everything, or square root both sides. Okay, so I would be looking for this as an answer. If it was multiple choice, or if it was a FRQ, that's where I would stop. But if I look at the answers on the back, it looks like they went from here and just made it where nothing had a fraction. So they multiplied everything by 3. And then added this over. So again, why did they do it that way? I don't know. But I could tell from my work that my work is equivalent to their work, so it doesn't really matter. Okay, anything jumping out at you about question 3 you'd like to ask? Okay, go ahead, keep going then. You don't need to be working on that right now.
And anybody like longer for question 5? Okay. Okay. I'm going to go over question 5 if you need it. This one should look familiar to you, hopefully, because I think we did this exact same question in your notes. But step 1, separate the variables. So personally, I would rather think of 0.75 as a fraction, but that might just be me. Since dr is in the numerator on the left side, that means all my r stuff needs to move to the left side. So I could divide both sides by r and multiply by both sides by ds. So that's one possibility to separate the variables. Remember, these numbers can go either place. So if you'd rather multiply the 4 up here, if you'd rather multiply the 3 down here, or divide the 3 down here, that's fine too. The constants can go whatever side you think is going to be more appropriate. Oh, actually, maybe we didn't do this one in the notes. This one looks a little bit different. Anyway, so we integrate both sides. The right side is ready to go. It's 3/4 times the antiderivative of 1 ds, which would be 1s. Put down my plus c before I forget it. But over here, 1 over r would have to be the natural log of the absolute value of r. And I'd say one thing about this question that might have been a little bit harder is you may not have known what you were solving for. Normally we solve for y equals, but there's no y in this question. So just like most of these are dy over dx, and we solve for y, this is dr over ds, so we should have been trying to solve for r. Okay, so this is a real telling moment to see if you thought of this process, because this is an algebra skill that if you'd ever seen it before this class, you probably didn't have to use it. You probably just got shown to it. But we can exponentiate the left side as long as we exponentiate the right side. The reason to exponentiate is because we have this property, log a to the log base a of b just equals b. The same way e to the log base e of the absolute value of r becomes the absolute value of r. And I haven't looked at the answers on the back yet, but there's a 99% chance that they're going to split this up. I just know that they do that often. So the same way that when you multiply things with the same base, you add the exponents. I want to unadd the exponents. So this is like e to the 3/4 s times e to the c. And I suspect, again, I'm not looking at the answer until I think I'm done, but I suspect that they do that because e to an unknown number is just a different unknown number. And I don't have an initial point to know whether this is supposed to, well, it's actually okay either way. This absolute value I can just make disappear. Now, last class we talked about if you have an initial point, you can make sure that the initial point goes through what you have, and you may need to multiply this side by a negative. Mathematically, you didn't have to worry about that here, because whether r equals this stuff or if r equals the opposite of this stuff, both of those can be absorbed in this unknown number. That we could just make the unknown number negative if it's supposed to be the opposite of the other stuff. So that is what I would do for a free response. But now to look at their answer and to see if they did anything different, they did not. They did exactly what I did. Well, other than they changed 3/4 to a decimal. But so separate, integrate. Don't forget your plus c. First three parts were pretty straightforward. Solving for r equals was not straightforward. You have to exponentiate both sides. That's the only way you get the r out of the logarithm. Again, the most common mistake is y'all try to treat this like times. It's not r times the natural log, so you can't just undo times with divide. It's natural log of r. Natural log doesn't mean anything without the r. You can't take the log of nothing. It's got to be log of something. It's a function, so it has to go together. Okay, is there anything specific about 5 you would like me to address? Okay. I will leave that up and set a new timer. I'm also going to kind of come around just to see how it's going. I'm just curious if some of you guys are going much quicker or if most of you guys are on the same pace as me. I just kind of need a little bit of feedback. So as I come around, if you have a specific question you want me to look at your work, just let me know. And I can try to help you while I'm around. Is it the integrating of this? Okay, this one I would recommend use u substitution. If you make u be the natural log of x, the derivative of u would be 1 over x, which is the other side. So you're going to be able to rewrite all that 1 over u. So it'll work out nicely if you take u to be natural log of x. But you'll have to do u substitution. Okay. Okay. Well, let's see. Wait, what happened to your equation? What happened to your equal sign? Well, this is, look, here's the equal sign, equal sign, equal sign. And then it, oh, okay, so you're saying that's equal to 0. Okay. Your answer is almost theirs. They just have rearranged it a bit, I think. Subtract your c back over. So even if you put it all on one side, you still need to say equal 0. I still need to see. Now when you subtract c over, c is an unknown number, so just leave it c. Don't call it negative c on the other side. Okay, and then another thing I compare about their answer to yours is yours has fractions and theirs does not. So if you multiplied everything by a 3 and a 2, what does it look like? Well, everything. You can't just multiply. You can't pick and choose. If you're going to multiply something by 3, you got to multiply all by 3.
I'm just supposed to, like, am I supposed to do that, or do I have to simplify that much,
So, okay, and then equal c. I want you to try to solve for y equals. And then if their answer looks different, just like it could be on a multiple choice question, you can do it right, and then the answer just might be a slightly different version. Make sure that you know how to change your version to their version.
It doesn't look like the sheet.
That looks good. That looks good. That looks fine. You could leave the 3 over there if you prefer to. This is off. There would be a chain rule step. The derivative of natural log of 3y is 1 over 3y, but also times 3 for chain rule.
It should be 3 ln.
And I wouldn't do u substitution there either, but if you did do u substitution there, that would catch that for you. That looks fine. Exponentiate. Now this 3 to exponentiate, this isn't e to log base e is some stuff, there's a 3 there. So you actually need to bring this 3 up at one point. So it's not coefficient. And then try to finish it from there. Like that. Oh, that's yours? Sorry. I mean, it's still it. Okay, would you guys like an extra minute or two for number 7? Again, I have no preference. Just don't want to waste your time. Okay. So, I was getting a few questions about number 7, so I don't know. Maybe this one's a little bit harder. I have not worked these again yet this year. Okay, so one thing that is certainly different about number 7 than 1, 3, or 5 is I can't see the dy dx. So take one step, and in fact when you write the question down, you might as well just change y prime into dy dx. It's hard to see how to separate the variables if you don't see the dy and the dx. Alright, the fact that dy is in the numerator on the left side means in the end all of my y stuff needs to go to the left. At some point, or right now, I can multiply dx by both sides, and now dx is in the numerator on the right side, so I know the x stuff needs to move to the right. I could also divide this side by 2 plus x, so divide this side by 2 plus x. Now all of my x stuff is on one side. to move this y stuff over, you can either divide both sides by y, or you can divide both sides by 3y. It's totally up to you. There's no, I don't think either one is easier or less easier. But if you have a 3 here, it just changes how this guy integrates. If you leave the 3 up here, it's one or the other, then this guy integrates a little bit differently. I personally think this looks a little bit better, just because this is going to be easier to integrate. If you put the 3 here, you're going to think this integrates as natural log absolute value of 3y, but as long as you check your answer, you're going to realize that you are going to multiply by 3 because of chain rule, and there's no 3 there. So you either have to undo the power rule, or I'm sorry, undo the chain rule in your head, or do you use substitution, or you could just leave the 3 over here. This is 3 times 1 over this stuff, so natural log absolute value of 2 plus x. So again, I'm not saying that you couldn't have a 3y here and a 1/3, but if that's the case, you don't have this 3. So your step could look different than mine and still be okay at this point. Okay, and then finally, I need to dig this y out of this natural log. So at the very least, please make sure that you know how to start this. Make each side of the equation the exponent on e. Again, I would totally understand why you had forgotten about this logarithm property, since it has never been important to you, but it comes up in lots of these questions. A number to the log and the base is the same number of something, it just comes out to be the something. The same way this is e to the log base e of some stuff, and it just simplifies to be the stuff. That's the only way you're going to ever get that y out of the natural log like that, is the exponentiating step. Okay, now again, I was right on the last question, so I'm suspecting that they're going to do the same thing here. But this, all of this is the exponent on e. This exponent is being added, so I'm going to unadd these exponents. I'm going to call this e to the c times e to this. And one reason I'm doing that is because e to the c is just c. The number e to an unknown power is just a different unknown number. And then be very careful here. I did see at least one person almost make this mistake looking at their work a minute ago. This does not match this format yet. Sure, I've got an e, log base e, some stuff, but I can't just pretend like that 3's not there. This doesn't say anything about a number being here. So you have to remember with logarithms that if you have an exponent on something you're taking the log of, typically you bring that exponent down, but you can also bring that exponent up. And now I've got e to the log base e of some stuff, and so that is just going to become the stuff. So solving for y equals needed the exponentiating, and the exponentiating is definitely the most common place to make mistakes. Now, if I start to look at the answers, I suspect their answer is written a little bit different than mine. And actually not really. All they did was, we don't have enough information to know how to change this, so all they did was drop the absolute value, and for whatever reason, instead of saying 2 plus x, they said x plus 2, but those are the same thing. So separate, integrate both sides, don't forget c, solve for y equals. That's where that answer came from. Okay, so there's the whole thing for 7. Any comments, questions, suggestions, anything about 7 before I move on? Okay, one thing I do want to add at the end of this question is remember the scoring. Next class we will look at a couple FRQs where this is part of the FRQs, so you'll see how this scored. But if you're struggling to get the final answer right on a regular basis, don't feel overwhelmed. As a multiple choice question, typically they either make them pretty basic so that you can do them in a reasonable amount of time, or as a free response question, they tend to give you 1 point just for separating the variables. They give you 1 point if you can integrate both sides, sometimes 2 points. Sometimes they give you a point for remembering C. Sometimes they give you a point for solving for C. That doesn't make sense in this question. And then there's always 1 point attached to the end. So of the 5 to 6 points they give you on free responses for these, it's pretty much spread out throughout the whole thing. If you can do about half of these questions, then you tend to be able to get all but 1 or 2 points from the FRQ, which you should be aiming for 100, of course, but as you guys know, FRQ averages are usually lower. So anyway, for whatever that's worth. Okay, I'm gonna leave this up for a few minutes. If you do see a question about 7, go ahead and just let me know. Also, I don't know that you guys have been paying that close attention to the questions, but if you look at the even questions on this assignment, the even questions are the ones we did together on the first set of notes. Actually, the notes you turned in today that I need to read. So in theory, you could also work those even questions if you know you need extra practice, and then you could look to see how we did them on the notes to make sure you're doing them correctly. Is it too early to look at question 9? Okay. If you weren't able to finish 9, please join me on the board here. So I've got y times y prime equals 4 sine x. So change the y prime into a dy dx, of course. This dy is in the numerator on the left, which tells me the y stuff ultimately is going to end up on the left. The dx needs to be multiplied over. The 4, you can do whatever you want. You can leave the 4 on the right side, or if you prefer to divide the 4 over to the other side, you can. I don't see why either one would be easier than the other, so I just tend to leave it alone. So there's the separation of variables. Okay, the reason you separate the variables is so that you can integrate. Sometimes that's undoing power rule. Sometimes that's undoing derivatives we memorize. Third step, remember your plus c. Finally, the purpose of these, solving a differential equation means you're taking a derivative equation and trying to find the original equation. So I can multiply everything by 2 and then square root everything. And so as a free response, I would circle it be done. As a multiple choice, I would look at my answer choices and try to match up with oh, and I have a mistake, don't I? What mistake did I make? Right, so I didn't, when I did this antiderivative, I just did it too quickly. You should always, once you do the antiderivative, check it by taking the derivative. The derivative of cosine is not sine. The derivative of negative cosine is positive sine. So this was supposed to be negative, this was supposed to be negative, so this was supposed to be negative. So hopefully, oh, okay, so then I can just take this, and the only thing they did is they switched the c and the -8 cosine x. So I don't know why they would switch those two, but that's all that they did. But learn from my mistake here. The derivative of cosine is not sine. The derivative of negative cosine is positive sine. That's very easy to miss, especially when sometimes we're doing derivatives and sometimes we're doing integrals and sometimes you multiply by negative and sometimes you don't. The best thing to do is once you write it down, check it. And don't skim over it like that I did. Okay, anything else about number 9? Okay. How about number 11? Anybody still working on 11? Okay, then I'll go ahead and talk about 11 also. Again, I'd like to go over as many of these with you as I have time to, so. Okay, so 11 also gives us a y prime in the question, so I might as well just change that before I forget about it. Okay, if this dx is in the denominator, I know I'm going to need to multiply it over at some point, which means the x stuff needs to ultimately end up on the right side. So I also need to divide by this square root mess. And assuming I didn't do any illegal math operations, you know, I add something to one side but not the other, anything like that, this should be fine. Okay, now I should be able to integrate both sides. So the left side should take you about a second. Just y. By the way, this is going to be good, because if I'm going to solve for y equals, at least that side's going to be done. But to integrate this side, you can spend as much time on it as you want to, but until you break down and do the u substitution process, you're probably not going to get it correct. U is probably this stuff. du is -8x dx. I need a 1x dx. So I have to substitute negative 1/8 du for x dx. And this I can call 1 over the square root of u, or u to the negative 1/2. So again, u substitution's not my preference either, but when we need it, we need it. So, okay, now I can actually integrate, raise the power by 1, don't forget your plus c, and divide by the new power. Dividing by 1/2 is the same as multiplying by 2. And I'll plug this back in for u. Okay, so that's what I would circle as my answer for free response. Multiple choice, I look at the answers, and their answer is exactly the same as mine. So, of course, that's the one that I would pick out. Don't need to rearrange it at all. So, separate, integrate, don't forget your plus c, solve for y. Separating wasn't bad, solving for y was already done, but the integration, left side was easy, right side, you have no option but use substitution. You're not going to see this and think, oh yeah, this is what I need the derivative of. Okay, anything stand out specific about number 11 you'd like to ask? Okay, I'm going to give you a little bit more time here then. I'll leave 11 up on the board and give you some more time to make sure that you get through number 13 next. Okay, if you got stuck on number 13, I'm about to go over that one, so feel free to follow along if you need it. All right, so another question where we need to change y prime into dy dx. This one looks like it's got more going on. Looks like I'm going to need more steps to separate the variables. I could add this over. And I don't know, dy is in the numerator on the right side, so I'm going to move all my y stuff to the right. I divided both sides by y. And then I'm going to move all my x stuff to the left. So divide by x and multiply by dx. So harder to separate than some of them, but not impossible. Okay, and then now that the variables are separated, I can try to integrate both sides. The right side is at least one that we just memorized. I'll put down my plus c so I don't forget about it. The left side, I feel like this one's not too bad, but to play it safe, I am going to do u substitution. I'm a little worried that I might mess that up. So this is like u du. So this would integrate as 1/2 u squared. 1/2 u squared. I'll plug the u back in. Okay, and then looks like last task is trying to solve for y equals. So I don't know. This is just a preference thing, but I'm going to switch the two sides. I just like my y to be on the left side. I just feel a little bit more comfortable that way. Okay, I could subtract this plus c over, but if I take an unknown number, if I take 0 and subtract an unknown number, it's just a new unknown number. So I can leave that plus c, even though it's minus c compared to that c. They're not the same c. And then at some point you had to realize the only way to move forward was trying to exponentiate. So again, I know you've practiced this less than others, so it's fine that if this step's hard, but hopefully you're at least seeing when you need to try to exponentiate. So e to the log base e of some stuff just becomes this stuff. Over here, we can split this up. Again, maybe not something you would normally think of, but you can see they ask you to do it on about every question. So this is like e to this times e to the c. And I just suspect that they're going to do that because now e to the c can look a lot nicer. The number e to an unknown power is just an unknown number. Okay, I don't have an initial point to deal with these absolute values, so I just have to assume that they disappear. If I'm wrong and this side's supposed to be negative, that would be absorbed by this constant anyway. If like this c was supposed to be 5, but this side's supposed to be negative, we could just pretend that c is negative 5. So, and then finally up here, there's one more thing I know I need to do. So this almost is that same log property as this. E to the log base e of some stuff is just the stuff. This is not e to the log base e of some stuff. This is e to the 1/2 times the natural log of some stuff. So bring this exponent up. Just like exponents on something you can take the log of, you can also bring those coefficients back up. So that would be like e to the natural log of x, and that would just be x. So I'm hoping that we've got something like c to the x, and theirs looks different. So I must have something wrong, or
They just didn't bring the 1/2 up.
Oh, you're right. You're right. I just very surprised that they didn't. But you're right. I was right to here. But again, before you can do this log property, oh, you do have to bring it up. But then this is squared. This is not. That's, I kind of did it. I had the right idea. I just did it the wrong way. So now, e to the log base e of this stuff should just be, oh, no, I can't even do that at all. I've got natural log squared over 2. It's exactly the way it looks. Okay, so this is the last one in the assignment where these are all general solutions. So all of these just have C in the answer. They don't give you enough information to solve for C. But starting with question 15, they do give you information to solve for C. So 2 things have to happen on these extra question types. One is we're going to be doing the same steps as this, so we're going to keep getting better at that. But we also need to solve for a numeric value for C. And when we have absolute value signs, we actually need to put some thought behind them to make sure that we make the other side correct, like we talked about last time. Okay, I'm going to just go ahead and go over number 15. I know some of you had not had time to try it, but again, the directions are just a little bit different, so it doesn't hurt you to get a little bit refresher about what's different on this one anyway before you do more like that. Okay, so on its face value, this is a differential equation. It's an equation because it has an equal sign. It's a differential equation because there is a derivative. So the same steps still apply all the way up to the 3rd step. We need to separate the variables so that both sides can integrate. Sometimes that's undoing power rule. Sometimes that's undoing one that we memorize. And then the 3rd step is solve for plus C. Now, this is where this one becomes different than the first 7 that we did. For this question, we have information that we can solve for C. So you can simplify this sum first and then solve for C, or you can solve for C now. It does not matter, but wherever you start solving for C, that's where you need to plug C back in. So if I plug in 0 for x and 3 for y, I would get 2 times 1 plus c is equal to 9/2. Subtract 2 from both sides, c would be 1/2. And since I started solving for c here, that is where it has to get plugged back in. If you multiply everything by 2 first, but solve for c here and plug it in a different spot, you're plugging a different c into a different c, so that just doesn't work. If I subtract 2 9/2 minus 8/2, 8/2 would be 4. Okay, my bad. 9/2 minus 2 would be minus 4/2, so 5/2, yes. Thank you. Okay, and then before I suspect to see my answer, again, this one's just a little bit easier to solve for y equals. Multiply everything by 2. Take the square root of both sides. Now, I will say that I think these are harder because having to solve for c correctly and plug it back in for c correctly adds an extra step or 2. The nice thing about these questions is, remember, your answer is supposed to go through this point. So if your answer does not go through this point, there's a 100% chance your answer is wrong, and you should stick with it longer. But if it does go through 0, 3, then you should feel pretty good about what's going on. So if I plug in 3 for y and 0 for x, I get the square root of 9 equals 3, which is true, which means that that is probably fine. It's very unlikely that that's correct or wrong, and that still be true. Okay, and then the only difference is the way they listed their answer is they stopped right up here. So that would be easy for me to pick out. So same as the first handful of questions, but now you actually need to solve for C. But otherwise the steps should be the same. Okay, if you see a question about 15, go ahead and speak up. Otherwise, finish copying that down and move on to 17, please. Okay, I'm gonna look at number 17 if you need it. Okay, so 17 gives us a y prime, which I go ahead and switch to dy dx, just like we've done for 10 questions in a row now. And this one should not have a plus c in our answer because we should be able to solve for c. So first 3 steps, still the same thing. We need to maybe subtract this over. And we could divide both sides by a y. I'm going to distribute the negative and multiply both sides by dx. I don't know. Just try not to do too much at once. You don't want to make a careless manipulation mistake and then everything after that be for nothing. So, okay, so integrate the left side, which would be natural log absolute value of y. That's one we just memorized. Undoing these two would be undoing power rule twice. Okay, now you've got a choice. I guess you can finish solving this for y equals and then solve for c, or you can solve for c now and then solve for y equals. Mathematically, it shouldn't matter. Just if you have a preference, if you think one is easier than the other, then you should do that. I'm just going to go ahead and solve for c right now. I don't want to run the risk of forgetting. So, absolute value of 1 is 1. The natural log of 1 is 0. If I plug in negative 2 for x, this would be 4 times a negative 1/2 plus 2. So, looks like c was 0. C is 0 if we're talking about this c. That's not true if you simplify it some first. Alright, now to try to find this for y equals, I can see I'm going to need to exponentiate the left side and the right side, because e to the log base e of some stuff just becomes some stuff. A lot of times I split this up, but there's no benefit in splitting these up this time, so I'm going to leave it that messy exponent there. Now, we didn't need to do this on the first 14 questions, 1 through 14. To make this absolute value sign disappear, you need to be careful. It could be equal to this exact thing, or it might be equal to the opposite of this. Remember the quick example that I think helps you see. X could be 2 here, or X could be the opposite of 2. Both of the absolute value of both those answers gives you a 2. So, for you to know if you just let the absolute values seemingly disappear, or if you make them disappear and multiply the other side by negative, you have to use this initial point another time. If I plug in negative 2, 1 into this, I get a true statement. I get a true statement leaving this positive, so I'm going to leave it positive. If this was 1, or if this was negative 1 and this was positive 1, I would multiply this side by a negative. But to make these absolute value signs disappear, we actually need to question whether the other side's positive or negative. You have to plug that point in and see if you need to multiply it by a negative. Again, that didn't matter on the first few questions because we had a c here, and we're just making c the opposite of what it was if it needed to be negative, so it was already taken into account. Okay, so anyway, the solving for y looks to be finished. So for, what was this, number 17? Yep, and there's really not anything else you could do to that, so that looks that does not look exactly like their answer. I can tell it's the same, but they factored out the negative 1/2, which made this a x squared, and negative 1/2 times 2x There we go. Yeah, they just factor out a -1/2. Okay, anything jumps out at you about that one? Anything you want me to clear up while we got a minute or two here? Okay, then, unless you worked faster than me here, again, I tried to give you time to look at all those. You could have up to 3 more homework questions, 19, 21, and 23. So remember, there's no school tomorrow, there's no school Monday, so the next school day is a B day, so make sure that you finish up those last 3, 4 questions that you may have, so that you get those homework points. If you need to copy down the last couple questions, now would be a good time. If you want to get out your phone and take a picture of that section of questions so that you have access to that, that would be fine. But do not keep the book handouts, please. You need to play with those handouts back. Again, we still don't have our test for a few classes, but you should have some idea of how much you're going to need to dig in on these separating the variable stuff. It does take more practice for some people. So. Oh, I'm sorry. I meant to pass back your homeworks, but we only have about 2 minutes. So, if you want your homeworks back today, that's totally understandable. You're welcome to come get your homeworks back. Plus, any other time that there's your name on it, it'll be in the homework box over here. I don't have time to pass them all back before you leave, so if you want yours back today, please come get it. And if you're happy getting it next week, then that's fine too.